Hi, I'm Kaylee, and in this lab I'll be analyzing the constant velocity of a moving object. I use both Tracker, which is a program that allows me to track the movement of the object through a video, and then GlowScript, which is the computer-generated program. In this experiment, the object in motion is the system and everything else is the surroundings. And this lab is to better understand the properties of Newton's second law, the momentum principle, and how they can be showcased on an everyday object. So Newton's second law and the momentum principle, there's three formulas. The force equals mass times acceleration, force equals change of momentum over change in time, and then momentum equals mass times velocity. And then in this lab, the velocity and mass of the moving object are constant, and therefore the momentum principle tells us that since mass and velocity are constant, momentum is also constant. And then we can also use Newton's law to determine that the net force on the object in the lab must be zero because there's no acceleration acting on the object. So here are the screenshots of the points from both my observed graph and points in Tracker, and then my predicted points and then graph from GlowScript. The blue is the predicted and the red is the observed. And clearly there's a few differences, which I will elaborate. And then here's a screenshot of my code from GlowScript. I changed line 32, or I left line 32, which was the ball's mass, because in Tracker the ball's mass was 1 kilogram, so I left it as 1. But I did change lines 35 and 36. I changed the x component of the ball's position and then the x component of the ball's velocity. And then I left time at 0 because initially the time was 0. And then I changed delta t to 0.033 because in Tracker that's the amount of time between each time step. I left net force as 0 because there's no net force on the object. And then in lines 58 and 60, I applied the momentum principle and changed the ball velocity formula and included F net over mass times delta t, and then included the ball velocity times delta t in line 60. And then this is what the program in GlowScript looks like when I run it. There's a position versus time graph. Clearly has a very straight line, very constant slope, and then the velocity versus time, the line is straight, and the velocity is not changing at all. So it's clear here that in the observed experiment with the video and Tracker, my human error made the points not as exact and precise as they are in GlowScript with the computer-generated program. And also you can see from the red line that it actually kind of sloped downwards, and the slope was decreasing at the end. And that's because there's some other forces acting on the object in the video that we can't control because it's natural. Could be friction, air resistance, or any other natural force that isn't present in the computing model, which makes it more accurate. Also, for what ifs, in Tracker, I could have made the window a little bit smaller, which maybe could have made the line more accurate and more like the predicted model. I could have made it bigger, which would have made tracking the object a lot less accurate, and the change of velocity would have been a lot less accurate. If there was more friction, the graph definitely would have slowed down, and maybe the object would have even stopped, and the velocity definitely would not have been constant. The velocity is constant, which means there's no acceleration, no net force, but it's hard to simulate that when there are natural forces that are always present. And basically the experiment is showing that while velocity is constant, the observed data will always have other factors on the system that we can't control. But in the predicted simulation, the velocity is constant, there is no acceleration, no net force, and momentum is constant.